Good morning. Now, however, we will discuss the issue of measurements, that is, during or after commissioning, we take measurements of the installation, meaning we measure the airflow at the supply and exhaust points inside the building to check whether they meet the design specifications. One of the final stages of installing a ventilation heat recovery system is the so-called white assembly, which means installing the supply and exhaust diffusers in the rooms. But to do this properly, for example, we have a nipple box where an extension is mounted to the box. And this extension sticks out from the ceiling. So if it sticks out just enough to be flush with the suspended ceiling, that's fine. If not, we need to remove or cut off the excess length of the duct. The diffuser itself is mounted to a frame, and we attach the diffuser frame to the duct or pipe. If it fits snugly into the extension or directly into the box, then everything is fine. However, if the element is loose, one solution is to screw it in from the inside using a self-tapping screw, so that the diffuser frame can't slide out or fall out of the box or extension. Once we've stabilized and properly installed it, we then mount the diffuser itself in place, twisting it as needed, and then we move on to the adjustment process, which means measuring and adjusting at the supply or exhaust point, or directly on the diffuser. Now we'll show how to mount it to a MUF box, meaning directly attaching the diffuser frame to the box. We remove the diffuser frame, that is, we detach the frame from the diffuser itself and mount it onto the MUF box. If it fits snugly, meaning nothing is loose, then we don't need to do anything. However, if needed or for extra security, we can screw in a short screw like a grub screw from the inside to prevent the diffuser frame from falling out of the box. With the frame mounted this way, we then install the diffuser itself by twisting it into place, and we also carry out the measurement and adjustment process to ensure the right amount of air is being supplied or extracted at that specific point in the room or building. We'll show an example of how to install an intake or exhaust grill on an EPS pipe. So let's assume this is our wall, and this is how much the EPS pipe sticks out to the other side, meaning into the layer of external insulation. To do this properly, we install a coupling on the part of the EPS pipe that sticks out from the wall. If I had two hands, it would be easier and more comfortable for me. Now we have the coupling properly installed on the PS pipe. Here we have the gasket. Sometimes the gasket can be hard to insert because there's no slip between the rubber and the metal. So it's a good idea to use some kind of lubricant. It can be something quite simple like, perhaps Ludwig dish soap, or alternatively, a specifically dedicated hydraulic connection lubricant where we carefully grease the rubber to significantly improve the slip, and then we gently push the intake or exhaust grill into the coupling, ensuring a secure fit. To secure the intake and exhaust grills to the wall, we usually screw anchors, so-called snails, into the insulation layer, most often polystyrene. Then we screw stainless steel screws into the snails. This is precisely how we securely hold and firmly fasten the grill onto the wall, ensuring a stable attachment. I recommend using stainless steel screws because that way the stainless steel itself won't rust, for example, from contact with a regular steel screw or any other galvanized one. We're at the final stage of installing the entire ventilation and heat recovery system, which is the stage of measuring and adjusting the ventilation system in the house. We'll walk through the building and take measurements in every room using a measuring device, an anemometer, which I've somehow misplaced. Okay, here it is. What do we need to perform the measurements correctly? First and foremost, we need the project with specified values, indicating how many cubic meters of air should be supplied and extracted in each room. Secondly, a protocol where we can record all these values, both the design and measured values for each room. 3. Set the airflow value on the heat recovery unit, meaning the output that is specified in the design, the planned amount. 4. A measuring device called an anemometer. 5. A ladder can also come in handy sometimes. So, let's start our tour through the building with all these elements. I need to set it up for myself, okay. I have the anemometer set to cubic meters. I'm a bit too short for this room, so I'll make use of the ladder. The heat recovery unit is set to 500 cubic meters of air. Just to remind you, all the measurements we take are done in a finished building, which means first and foremost, the doors must be installed and closed, and those doors must have the proper openings to allow for airflow, just as a reminder. In a room, that's at least 80 square centimeters. In the bathroom, that's at least 220 square centimeters of effective cross-section, meaning a cross-section that isn't blocked by anything when it comes to the opening in the door. We're in the kitchen, where the kitchen is supposed to have 70 cubic meters of air according to the design, but according to the measurement, right now, it's 57, so that's a bit too little. So we'll look for where we have more, so we can adjust that 57 there. We're in the pantry now. Oh, what a nice sound. Let's try to measure the airflow here now. According to the design, we should have 15, but we've measured 23. We could maybe turn it down a bit more, although there's really not much room left to do that. When it comes to adjusting the installation and the whole ventilation system, we should start the adjustment process with a properly executed design. That means designing the right amount of air and choosing the appropriate duct lengths. Second, proper installation of the system according to the design, or if there are any deviations from the design, then in line with the guidelines and principles discussed in the theoretical part of our course regarding installation. So, for example, if we have sections that are too short or too long, what should be done in such cases? Third, we have the ability to make adjustments at this stage. That is, measurement and regulation using balancing dampers, which we install at points where there is too much supply or exhaust air in order to throttle it. This is because a ventilation system, especially a manifold system, works like a set of interconnected vessels. If there is too much air in one place and too little in another, to ensure that the area with too little air gets the right amount, we need to restrict and balance the airflow where there is too much. Alright, we're in the room called the living room. According to the design, the entire living room should have 125 cubic meters of air. At this supply point, we have 4345. Here, we also have the numbers 46 and 47, so we can also reasonably assume the number 45. Let's carefully observe what is present at the third position. At the third point, we have 38. So we have 45, 45, that's 90, and 40. That's 130, right? Roughly. Alright, we can move on. We're in the room downstairs. In this room, we have 40 meters, we have 50. So we can try to even that out. Okay, now exactly 44 and then 45. Oh, right, adjusting with the dial is basically no adjustment at all, as we can see here in the attached picture. Here, we can maybe adjust it by 2 to 3 meters, but I've already tightened it more than halfway and we still have exactly the same measurement, the same value. So we'll go through the rest of the building. And we'll check how the air volume is in the other rooms. If we find we're short somewhere, we'll come back to this room and install a restrictor. But okay, for now we have 36 meters. The room originally labeled as a walk-in closet has been converted into a server room. According to the plans, it should be 15, but our measurements show 17. Measurement error up to 10% on the anemometer with the tube. Alright, we can move on to the next room. The vestibule, as per the design, is 15 meters and meets the regulations. A windowless room with air exhaust. 15 meters. It's worth installing exhaust ventilation here, meaning an air exhaust in the vestibule, because during wet seasons, spring, winter, autumn, we usually leave wet things here like shoes, jackets, or other items, so it's a good idea to remove the humid air from this space. Hey Philip. Measurement value, project specification is 15, measured value is 17, right? Vestibule. We're in the bathroom now. According to the project, the bathroom should have 50 meters. According to current regulations, that is, according to the Polish standard PN 03430, the measured value is 52 meters. Pretty much perfect. So at this point, we've finished the measurements on the ground floor of the building. We're moving up to the first floor. Let me invite you to the next part of the tour. We're on the first floor now, so again, using the project and the table. From the air balance, we have the individual values for supply and exhaust air in all the rooms. It's best to copy this into the protocol. And let's get started. We're in the hallway. In most cases, we don't recommend installing an exhaust point in the hallway, but this is a special case because we have an open space, a mezzanine, so all the air that gathers here rises up, and it's worth removing it from here. However, it's not worth installing the exhaust point in the optimal spot, meaning at the very top of this room, because we would have difficult service access, both for measurements, adjustments, and later, for example, replacing the FSA cone filters. That's why the point, which theoretically should have been there, was moved to this spot, where it lines up nicely with the lights and we also have easy access to it. Alright, the design value. The intended measurement was 20 meters. However, the actual measured value obtained was precisely 25.29 meters, so we can adjust it a bit. The adjustment didn't do anything. Seriously. Alright, 25 meters, give or take, right? So we can move on. Of course, like I said, the more accurately we do this, but we also don't have to be super precise about it. Just a reminder about the measurement error on the anemometer. Alright, we're entering bedroom number 1. Room number 1. Design-wise, it's supposed to be 50 meters. Right now, the measured value is 57/58. We can adjust that, but let's see how it is in the other rooms. (52/53), so we can leave it like that and move on. The walk-in closet. Design calls for 15 meters, but the ladder is in the wrong spot. Measured precisely at 20 meters distance. We can leave it as is or move on. If we end up missing something somewhere, we can come back and adjust it here. The master bedroom, where we have 2 supply points, but on one side of the bedroom there's an entrance to the walk-in closet, and on the other side there's an entrance to the bathroom. So taking into account the exhaust points, here we should have 85 cubic meters of air. 70 cubic meters for the bathroom, 15 cubic meters for the walk-in closet, because probably the door is without a cutout. No, it has a cutout. So that's how we can do it. All right, let's take measurements in this bedroom. Okay, 18 cubic meters. But that won't help anymore. A little bit. Especially since it is a short episode. Okay, here we have a significant 70. Break time equals 0.5s/. 90, right? All right, 22. 22. Okay, so 70 plus 22 is 90. That is... I would leave it at that. 20.70 PLN. Okay, now let's move on to the wardrobe. Wardrobe, design value 15, measured value 19. All right. Now let's go to the bathroom across the hall. Bathroom, design value 50, value changed under difficult conditions. $47 is acceptable. Okay, so we have the whole section, right? The bedrooms together with the bathroom and the wardrobe. It's balanced. We even have more supply air, right? We're in the laundry room, so according to the design, exhaust is 50 meters. Windows are closed, doors are closed. The value has been measured. With the anemometer actively running and providing real-time data, we observe the readings. Specifically, at 40 meters, the measurement registers at 38.38. All right, let's carefully proceed to thoroughly examine if we have an excessive amount of something present in any particular area, requiring our immediate attention and adjustment. Right now, we have 38. All right, let's keep going. Room 50 meters, running. Regarding the design value and the corresponding measured value, specifically the figure 59, we have determined that it is acceptable to leave this particular value as it currently stands. This decision applies to the large room where the value of 59 is relevant. Next room, right? So we have 50 meters. We've measured 47. We still have the bathroom left on this floor. We're in the bathroom now. Remember how, during the installation stage, we moved the point from the non-existent walk-in closet to the bathroom, and one of the points was installed directly above the sink. That means it takes away all the moisture that can be generated here while washing hands, and it also prevents the mirrors from fogging up. So here, for the entire bathroom, we need to provide 50 cubic meters of air. At this particular one specific point in time, we currently have a significant value of 44, and at the other distinct point, we possess a value of 30. So, in total, with the nominal and designated capacity of 500 cubic meters, we consequently have a substantial flow of 70 through the entire bathroom area. Yes, the bathroom is actually the kind of spacious and functional room where, in most cases, you would expect to find a variety of essential amenities and features, making it a truly integral part of any living or working space. This is where we produce the most moisture, so it's worth ventilating the bathroom intensively and properly, but you also have to remember that the bathroom is limited by the opening in the door, which should have a 22 centimeters active cross-section. Here it's probably a bit less, 40 and 30. And also, specifically in the case of RECU, Czech Easy Series recuperators with an installed air quality measurement module, carbon dioxide, and humidity, the device also responds to a spike in humidity that can occur in the bathroom. So basically, that's when we are taking a bath, a shower, or any other activities that increase water production. In such cases, the recuperator will measure it and respond by increasing the amount of air flowing through the entire building, which in this case also means through the bathroom, in order to intensify the removal of moisture from this room. Alright, so we've measured all the points, so now we should go through the entire building once more and measure all the values after these adjustments, meaning after this regulation. A slight adjustment to the air diffuser. In this case, we didn't need to install a damper, that is, a regulating throttle anywhere, which in short means the installation was well designed and properly installed, so we don't have to use that third option, meaning the emergency regulation with a damper, or rather the regulation with a control damper. One of the components used in a ventilation system is, for example, a long-range nozzle. To properly adjust the airflow through such a supply nozzle, we need to use nozzles, we need to use a damper, a regulating orifice. What needs to be done? You need to remove the cover from the nozzle, which has something like a screw, right? By turning or unscrewing it, we can remove it. We remove the long-range nozzle, and inside the duct from the plenum box, we install the regulating element, that is, a damper or a regulating orifice. In this particular case, we adjust it by turning or reducing the cross-section and throttling the flow on such a damper. With such an effective damper, we meticulously install the main duct from the primary plenum box and then carefully mount the short-range air nozzles. We take a measurement with an anemometer. We check what the airflow rate is. If it matches what we expect or require, we leave it as is and do not adjust it. However, if it differs from the expected or design value, you need to remove the nozzle and adjust the airflow on the damper accordingly. Then take another measurement. So, if we have set the value to what we expected or planned, the final step is to reinstall the cover on the long-range nozzle. Done. One of the elements increasingly used in ventilation systems is the slot diffuser, which can serve as either a supply or exhaust component. Such a slot diffuser can be installed either on the wall or in the ceiling of a building. But why is it being used more and more often? Because of its design and appearance, it's a nice decorative element that also serves this technical function, meaning it brings air into and out of the room. We'll show you how you can adjust the airflow through such a diffuser depending on your needs. So let's move on to demonstrating the adjustment. We regulate the airflow in the slot diffuser by properly adjusting the blades installed in the diffuser. If someone has long enough fingernails, they can use them, but I need a tool like a screwdriver to gently move this blade. We can adjust either one blade, or for example, we can also adjust the other blade. In this case, with this setting, we have the maximum airflow through the slot diffuser. So at the bottom, it's fully closed, while at the top, we have the fully open version. And now, by properly adjusting these blades and by measuring the outlet velocity from this diffuser slot, we can regulate its performance. The next part is the operation of the heat recovery unit, including the replacement of filters, whether year-round or seasonal ones.